area using a half the base by the height, and also by using the formula a half AB sine C equals the area. Yeah. So we're going to continue now with trigonometry. We have two more formulas to add to our list of formulas. So far, the sine rule and the cosine rule. So far we have Pythagoras. Yes, Pythagoras. Yes. We also have sine, cos and tan. We have a half the base by the height, and we have a half AB sine C. And we also know that the three angles must add up to make 180. Okay, so we have two more to look at, the sine rule and the cosine rule. So we'll have a look at the sine rule first. Now, the big difference between the sine and cosine rule and the previous rule is that so far the rules we had, they only really work if the triangle is right angled, if it has 90 degrees. But the great thing about the sine and the cosine rule is that it works for any triangle. This is its advantage. Okay, so let's have a look here at the sine rule. So we have any triangle, so I'll just imagine I draw the triangle like this, for example. And I'll call this angle A, this one B, this one C. Guys, what's wrong? Come on. Are you ready? Have you got paper? Hurry up and give her some. A, B, and C. Yes? Right. So what we'll do, this triangle is not right angle, so the angles A, B and C could be any angles. We're trying to find a formula that relates the sides and the angles together. Nathan, I will destroy you, and I'll make a YouTube video out of it, and it will go viral. And like, yeah, you show that, Nathan. Sorry to cause you trouble. Right. So the way we'll get the formula, the proof, is we'll draw a line straight down the middle. Well, not straight down the middle, but we'll draw a line and we'll make it perpendicular, and we'll call that the height h. What? This line here is the height. We know that sine A will equal what from this triangle? This one here. H over C. Yeah. And likewise, we know that sine C will equal H over A for this one. Now, we can say, well, that means that H equals C sine A, and then H equals A sine C. So therefore, we can say C sine A equals A sine C, which we can rewrite as A over sine A equals C over sine C. And this is actually the sine rule. You can include B, of course. You do the same thing. And basically you can end up with this formula. A over sine A is equal to B over sine B is equal to C over sine C. Or you can flip it as well. You can also say sine A over A equals sine B over B equals sine C over C. So this is what I mean when I say the sine rule. So when you write this down, we'll look at an example of how to use this rule. Oh, you're coming back for some sine and cosine rules, huh? Oh, no. Thursday? This is extra maths, possibly? Let me think. No, hang on, let me just check. When did we have extra maths? When was that?
We did that.
No. Yeah, no, I know that.
We've done Thursday.
In the past, when we did have it, when did we have it?
Thursday.
Thursday at 4.
So,
That is that's gone.
fantastic.
Oh,
Drop it down for next time.
what the heck? Why is there Thursday 4 here? Oh, so that's because it's Wednesday.
Yeah.
Yeah, sorry, I'm being tired.
That's it.
Oh, yeah, okay.
Drop it down.
Yeah, and that one there as well then, yeah.
There wasn't any extra.
Yeah, no, it's gone now. We don't need it anymore. They're so great.
Your book. Fantastic. Can look for this. Yeah. Thanks.
He needs that, otherwise he doesn't have the answers to the questions. Okay, have you taken that down?
No.
Oh, hurry up, come on.
Sine.
Yeah, you have this now?
Yes.
Yeah, okay. So, the idea is, if I just draw another triangle again here. That's not a triangle. Right. What we're saying with the sine rule is that if we were to take a side and divide it by the sine of the angle opposite, that's the same. So if we were to take this side and divide it by the sine of this angle, then it will be the same as the previous one. Or if we took this side and divided it by the sine of this angle, it's all the same. All those three calculations are the same. So I'll give you an example with numbers. Like, let's say this is 30 degrees and this is 2 meters, and then we'll say this is 40 degrees and I want this side. So the sine rule tells me if I take a side like 2 and divide it by the opposite sine, sine 30, that's the same everywhere. That will be the same as x divided by sine 40. And this is enough to give me the x. So let's see what we get. Yeah, don't ruin the surprise. Right. Yeah. 2.57 meters. Get the idea? Yeah. So you can do it, you can use this to find angles as well. So let me give you an example where you have to try and find the angle using the sine rule. Can I scroll down? Yes? So this is our first example. Next example. So let's see here. Let's say that this angle is 20 and this is a 6 centimeters or whatever. This angle I wanted, I'll call it x, and we'll say this side is 8 centimeters. Okay, try and find the x, please.
You want a meter?
No, the angle doesn't care if it's centimeters or meters. Okay, you have an answer here?
Yes.
Yeah. So we can say sine x over 8 equals sine 20 over 6. So I get sine x equals 0.456. So x equals sine inverse of that, 27.13, so 27.1 degrees.
So,
Yeah,
why can't you put the side on the top?
you can. You get the same answer.
Okay.
The reason I didn't is because it's a little bit easier to have the unknown up the top.
Okay.
Yeah. Okay. Can I continue now? You have this? Yeah. So that was the sine rule, so now cosine rule then. Yeah. Can you scroll down? Yes?
Yes.
Guys. Come on, are we listening? Yes. Alright. Okay, so again, cosine rule, we'll imagine we have any triangle, so I'll just draw a triangle here. This is A, this is B, this is C, A here, B here, and C here. So again, the proof looks pretty similar. This time I'll draw a straight line. Yep. Oh yeah, of course, sorry, I'm very hungry. B and C, thank you. Okay, we'll draw a straight line down again and mark it here. Yep. No, you don't have to know the proof for the exam. No, but it's good to see it, because for some of these questions you have to think about the triangle in steps. It's good to understand what's a good way to break down a triangle. So sometimes splitting into two is helpful. For some other problems, you'll see other things you could do. Right, we'll call this again, well, I won't I won't call this one. This time I'll look at the other side. So I'll call this side here X, from here to here. So how big would this piece here be? C minus X. Yeah? And I'll call this one H now. Alright, so if I use Pythagoras theorem, I can say, let's see, which one will I go with? I'll go with, well, one on the left, I suppose. X squared plus H squared equals B squared. And then I can also say C minus X squared plus H squared equals A squared. So I'm looking at this triangle, and then I'm looking at this one. Two Pythagoras here. That's A squared there. Now, I want to cancel the H. Actually, sorry, this isn't really an example, this is a proof. Okay, so I want to cancel the H. That's not so bad to do. I just have to subtract. So they'll cancel, and I'm left with X squared minus C minus X squared equals B squared minus A squared. Yeah? Let's expand. That's X squared minus C squared minus 2CX plus X squared equals B squared minus A squared. So I get X squared minus C squared plus 2CX minus X squared equals B squared minus X squared. Now that's great because two things cancel here. The X squareds cancel. So what I'll do is I'll take this one here, I'll take it to the left, and this one I'll take it to the right. So now I have A squared equals B squared plus C squared minus 2CX. So we need to do something about this X, because X was not in the original triangle. So if I go back up here, I can say cos A equals X over B. So then X equals B cos A. That's what I need to put in here for the X. So now I get A squared equals b squared plus c squared minus 2bc cos A. This is the cosine rule. Well, this is really everything that you need because the original is just a triangle, so this is everything here.
Could you explain how you got the b cosine A again?
Yeah, cos A adjacent over hypotenuse.
Got it.
Yeah. Okay, can you write this one down?
Cosine.
You have this? Now, there are other ways to state the cosine rule. So, in this version, you have the A on the left. But it doesn't matter. If you had other sides, they just cycle. What I mean by that is, if here was a b squared, then this would be c squared plus a squared minus 2ca cos b. And likewise, c squared equals a squared plus b squared minus 2ab cos c. They're all the same thing. I'll show you how to use it though.
You just, instead of finding the sine, find the angle.
For which? You can use the cosine rule to find angles or sides. But what makes it different to the sine rule is the following. Can I scroll down a bit? Yeah. So, you use cosine rule when you have side here, and angle. And usually what happens is you're looking for this side. Or the other situation where it's common is you have all three sides and you're looking for one of the angles. These are the two situations for cosine rule. When you have two sides and the angle between the sides, then you can find the missing side. Or the other situation is when you have three sides and then you want one of the angles. So I'll do the first one and then you can try one like the second one. Can I scroll down to the example? Not yet?
I think we even have to write this. It's pretty awesome.
For some and for others not.
So they want to look like you.
Well put, Hisham. Well put.
Thank you.
Yeah.
And I would even add to that saying maybe some of us don't want to be like him.
I didn't say that.
No, you didn't, because you are a good person, not like me. Yes.
Oh, I just had you on my Facebook.
That's it. No, I've just lost a friend on Facebook, have I? You unfriended me as soon as you get home. All right, can I scroll down now?
No, please.
Oh, come on.
Yeah.
Yes? Yes, okay. Right, let's have a look at an example here. So we'll say this side is 6, this one's 7, and this one here is 30 degrees, and I want this missing side. So the cosine rule is a lot like Pythagoras, because the start is the same. You would say x squared equals 6 squared plus 7 squared. So far it looks just like Pythagoras. And then the next part is the difference. You would say minus 2, 6, 7 cos the angle in between. So it's nearly like Pythagoras except for this extra piece at the end. That makes it different. So, using the calculator. I get x squared equals 12.25. So my x is 3.5. Yes.
I have trouble like deciding which one is like A, B, and C.
It doesn't... That's correct. Mm. See? Yes? Oh yeah, no, so I don't remember which way it is with ABC. In my head, the way I'm thinking about it is the side that I want equals the other two squared minus twice the other two cos the angle in between. So I don't label them in my head as ABC. I'm thinking about it like that. And with the sine rule, I'm thinking about it as the angle over the opposite side equals another angle over the opposite
Does it
side.
matter if you have like 7 squared plus 6 squared minus
No, it doesn't. It doesn't.
2, 7 times 6
Cos 30. No, it doesn't at all. Okay, let's have a look at another example. Can I scroll down? Yep. Right, I want you to try this one, please. 5, 6, and 8. So what I want here is, let's say, I want the biggest angle. Which angle would that be? The one here, here, or here? If we call that A, B, and C, which is the biggest angle? A, yeah, because it's opposite the biggest side. Right, so try using the cosine rule to find this angle.
Yay.
Okay, you have that now? Yeah, let's have a look. So you can say 8 squared equals 5 squared plus 6 squared minus twice 5, 6 cos x. So 64 equals 25 plus 36 minus 60 cos x. So 64 minus 25 minus 36 equals minus 60 cos x. So 64 minus 25 minus 36 is 3. So you have 3 over minus 60 is cos x. And then 60. Yeah, so here the x will equal 92.9. Yeah, 86, so 92.9 degrees then. Okay, you have that one? Yeah. Okay, not yet. Nathan. He's trouble. Okay. Continue, you have this? Yep. Now, we have some basic examples done with sine and cosine rules. But really for the exam, the sine and cosine rules usually come about as practical problems. So there's usually a diagram you're given some information. So I'll do a couple of examples to give you an idea of what I mean by that. So this would be a typical exam question. And in fact, you might even have seen it before in high school. It's such a common question. Okay. So there's a building here, and we're trying to calculate the height of the building. And we stand here at some point, and we don't know how far away that is. And we measure the angle to the top of the building. And in fact, this is very, very easy to do. Clinometer is what you use to measure the angle. It's a very simple device, but it basically lets you measure angles in your sight. So let's say we measure the angle here, something like 30 degrees. This is easy to measure. Then you take out a meter stick and you walk forward a distance of, we'll say, 2 meters exactly. Again, this is easy to measure. And then you measure the angle with the top of the building again. And this time the angle will be bigger, like something like 40 degrees or whatever. This information is very, very easy to get. And with this information, you can now calculate the height of the building. So let's see how we do that. So first, just draw this, please. And if possible, try to use 2 colors. So for me, what I'll do is I'll use blue for the information I give you, and then red for the information we find. Or I'll use green. No, I'll use black.
I'm sorry, Dad.
Yes.
How did we get to 40 degrees again? What is that?
That's given to you.
Given.
Yeah, everything in blue is given to you.
And the okay.
And we're going to add in that.
So what's not given is the red stuff.
Yeah, that's what we want is in red. What we have is in blue, and black would be our calculations. Okay, did you draw this? Yeah? Alright, so firstly, we start filling in the things that are easy to find. So, if this is 40 and this is 90, that's 130. The total should be 180, so what is this angle? 50. So we know that this is 50. If this is 40 and the total should be 180, what's this?
140.
140. If this is 140 and this is 30, what's this? 10. That's okay. Now, when we have 2 triangles, it is convenient to find the side that they share. So I'll call this side here x. And I'll use the sine rule. So I will say x over sine 30 equals 2 over what? Sine 10.
I use your black pen.
I don't have black. It's not black.
No, the one. Oh,
2 sine 30 over sine 10. So x is 5.759 meters. Okay?
so they asked us to find the so is that the height?
No, that's only getting there.
This is 2 over 10.
Sine 10 here.
Oh.
Now I know the x. And remember, this is a right angle triangle, and I want the opposite, and I have the hypotenuse. So opposite and hypotenuse, what could I use? Sine. So I can say sine 40 equals h over x. So that means h equals x sine 40. Do I know the x? Yes. And the sine 40? Yes. So, I get 3.70 meters. as the height.
Sine 40.
Huh? Yeah. Okay, do you have that? Yeah, okay. I think what we'll do is I'll let you do the first one in the homework and then I'll do it on the board. The rest of these questions will be for homework then. Now the people who have the book, this worksheet is very different to what's in the book. So for this worksheet you'll need to look at Moodle, okay? I want everybody to do question 1. It's not as difficult as this, and then I'll do it, and then we'll have a look at some more if there's time. They get very difficult, but they're all exam questions, so you need to practice them. So just try number 1, please, if you can open that. Can I scroll down? No, not yet? Okay. Well, in a moment I'll do number 1. So I'll give you 2 or 3 minutes to do number 1. Can you try it now, please? You'll do it, and then I'll do it. Yeah.
All of them.
No, are you looking at the book or Moodle?
I'm opening Moodle.
Yeah, question 1 has only one part.
Oh.
Yeah.
Basically, we're gonna finish trigonometry. When finishes?
Trigonometry will be definitely finished this week.
Yeah. Right. What the? Wow, work is really.
Now, I realize my graphics are very fancy and advanced, so do not be distracted by their awesomeness. Just try your best to question 1. Just try not to be distracted by it and do question 1 then. Yes. Try number 1, please.
حاجة لما قال لي المدة حلوة عجبتني. خطة حلوة. أنا المدة. خطة حلوة. حلوة عجبتني فعلا خط اسمه.
لا ماكسيموم رانج اوف دي
كده أنا عايز أعمل كده. والله حلو.
أول إيه
والله
والله كتير
والله
إيه الدورة كلها عايز
ده انت قاعد على القلب المسؤولية بتاعك
كل يومين
على أولى درسين ساعة بس مش نشوف الصف
ده ماكسيموم رانج اوف
بس
أول
انت عايز واحدة تنزع
ربنا يسهل
أسمع مسؤول
the maximum range of mobile phone tower is you pick up cosine
like an aerial view. So the tower's here at the center, and it's you know what I mean by range, like how far the signal can extend. It's 35 kilometers, so that's actually the radius there. And then what's happening is you're walking along, and if you look here, you pick up the signal on your phone here, and then you travel for 42 kilometers, and then the signal is lost. So you know from here to here is 42. That's enough information to work out the nearest you've got to the tower. So let's see the nearest to it. It'd be about here. So I want to know what is this how close were you to the tower?
Definitely get yes.
Yeah, close.
So it's like a triangle.
Yeah, you can form a triangle then, yeah.
Are we trying to find sides, right?
We're trying to find that shortest distance between the grey line and the tower. The closest you get to the tower.
Okay.
Oh yes, yeah. Which part? The 35? The radius? Yes. Oh yeah. Ah yeah, but I want the closest to get to the tower, and the closest will be here. So I want this distance. Oh yeah, this is way too easy. Yeah.
Is this way?
Not too bad, but I'll do it now.
Thank you.
Where'd I put my pen? Okay. Let's have a look at this now. Can you look up, please? So, here's the center here, and then you're traveling along like this. The information you know is that the distance from here to here is 42. But you also know that here to here
35.
is 35. Yeah?
Yes.
Now, if you look at this triangle, these two sides are the same. So what type of triangle is, yeah, the angles are the same. Isosceles. So this angle is the same as this angle. Yeah. And can you work out this angle?
Yes.
Yeah, easily. So if you know this angle, then you can know these two. And then if you have all three angles, you can easily work out this side. But you don't even need to use sine and cosine rule here, because this will be perpendicular, and this is x. Now, if I split this isosceles triangle down the middle, then these sides must be 21 and 21. Now, the only reason I know that is because it's isosceles. Because the angles and sides are the same, when I split it down the middle, it'll be exactly the same on both sides, because it's a mirror. So I only know this because it's isosceles. So now if I look at this triangle, this is 21, this is 35, and I can get x from Pythagoras. It'll be 35 squared minus 21 squared. What's that? 28, is it? 28. Yeah. Yeah, so in the question I said the maximum range of a mobile phone tower is 35 kilometers. So in the picture what I mean is the signal extends out 35 kilometers. So that's why the circle is there. Then it says you pick up the signal on your phone and you assume you are just about in range. So just about in range means you've just entered range here. And then you travel for 42 kilometers, and then the signal is lost. So you must have left here after 42 kilometers. So that's why I know this is 42 and these are 35. You're looking at this from the top. Is that okay?
How do we know about x? We have to find the x.
Yeah, and then the question said, so, what is the nearest you are to the mobile phone tower? So at the beginning, how far away are you? 35. And at the end, how far away are you? 35. So somewhere in between you are closest to the tower. When you have a line and the point, the closest happens when we are perpendicular. That's when the nearest happens. So that's why I'm looking for the perpendicular here. Is that okay? Yeah? There are 10 questions in total. Just so you know, there's a small mistake in number 2, just so you can remember. Wait, just remember this, In number 2, listen, in number 2 I said radius, but I meant diameter. Just remember that. Now, there are 10 questions. This is the first question. You need to do all of these because these are all exam type of questions. And in fact, I can tell you which ones I've seen in the exam. 3, 4...
Six would be,
6? Yeah. So let me just put it this way. I tried to put the questions in order. So like question 1, 2, 3, they're kind of easy ones. In fact, maybe this is even too easy for the exam. 4, 5, 6 would be normal exam questions, and then the last ones are like 7 to 10. You could still get them on the exam, but if you did, they'd be considered difficult exam questions. So you really do need to try all of these, especially 1 to 6. You can try the last few because they could come up on the exam, but you will find some of them difficult. Okay. I have a feeling that the tutorial this week will probably be these questions. What you probably, I think, get. So try your best to do all 10 of them, and the ones you have trouble with, we'll do them in the tutorial then later in the week. Okay? Alright, so it's just one class, isn't it? Yeah.
We had extra maths, right?
No, I don't think so. If you want